Hello and welcome to a special GCSE revision video. This is a practice question on algebraic fractions. I've racked my brain to come up with probably the most ugly and complicated question that I can think that the most malicious examiner could possibly come up with. And this is the nightmare that I've managed to give birth to. Okay, so I'm just going to make this small enough so that we can fit the whole thing on the page, and that should clearly be visible. Okay, pause the video here, take your time, have a think about it, and when you're ready for the solution, just press play. Okay then, so how did you get on with that? Let's just return this to the normal size so I can see what I'm doing. Alright, so it says express as a single fraction 2 over a minus 1 plus b squared minus 4 over 3 times 3 over b minus 2 into b plus 2, given that a is not equal to 1 and b is not equal to plus or minus 2. And then it goes on to say, use your answer to show that if a is greater than 1 and b is not equal to plus or minus 2, that all of that ugliness is greater than 1. Okay, so that might look like something out of our nightmares. So first of all, let's have a look at what are these conditions here. A is not equal to 1. Well, that's fairly clear because that would make this denominator equal to 0, which would make the whole thing undefined. And if b is not equal to plus or minus 2, that would make this denominator here 0, which would also make the whole thing undefined. Alright, so given these stipulations, let's see if we can simplify this. Alright, so we've got to add first and then we multiply. So multiplication takes priority over addition, so I'm going to do the multiplication first. So we've got 2 over a minus 1 plus, now I'm combining these two, so to multiply fractions we just multiply the numerator and denominator, so that's just 3 into b squared minus 4 and all that's over 3 into b minus 2 into b plus 2. Okay, well the first thing that springs to mind is that I've got a 3 on the top and bottom, which can just be cancelled, so that gets rid of the 3. And the other thing I noticed is that b squared minus 4, that's the difference of 2 squared, that's equal to b minus 2 into b plus 2, which is the same as the denominator, so that's going to cancel out. So this whole ugliness is just going to turn into 1. So I'm actually going to show that as a step, because you might get marks for that in an exam. Just for showing I know the difference of 2 squares. So that's b minus 2 into b plus 2 all over b minus 2 b plus 2. And then b minus 2 cancels with the b minus 2, and the b plus 2 cancels with the b plus 2, leaving us with just 1. So this is equal to 2 over a minus 1 plus 1. Okay, well we can combine this if we say that 1 is the same as a minus 1 over a minus 1. So this is equal to 2 over a minus 1 plus, this time our 1 is the denominator over the denominator, so that's just a minus 1 over a minus 1. Now that we have the denominators the same, we can combine the numerators. So that's equal to 2 plus a minus 1 all over a minus 1. And now 2 minus 1 is 1, so this is equal to a plus 1 over a minus 1. And that's about as simple as we can make it. So all of that ugliness actually simplifies to something not too complicated at all. Right, so now we're told use your answer to show that if a is greater than 1 and b is not equal to plus or minus 2, that all of this rubbish is greater than 1. Well, the first thing I'd want to say is that all of this rubbish is equal to what we just decided, or what we just calculated. And now we can say if a is greater than 1, then a plus 1 is positive. And again, if a is greater than 1, then a minus 1 is positive. And if a is greater than 1, then all of this is positive. Therefore, oh sorry, I should point out before I make that conclusion, for any value of a plus 1 is always going to be greater than a minus 1. And therefore the numerator is greater than the denominator. And therefore a plus 1 over a minus 1 is greater than 1. Basically, for any fraction, if the numerator is bigger than the denominator, then the whole fraction will always be greater than 1, provided the fraction is positive, which is why I went to the trouble of making sure that it was shown that the whole fraction has to be positive. Okay, I hope you found that helpful. Don't forget to like, comment and subscribe. Like this if you want more questions on algebraic fractions. Comment if you have any suggestions of other GCSE maths related videos you'd like to see me make. And use the subscribe button if you want to be notified if I make any more videos. Okay, if you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams, and I look forward to seeing you in another video.